Now the next example is not exactly a rational function, but it kind of seems like one. As you can see, the denominator is a polynomial, the numerator is not. It's the square root of x plus 4. Right? So it's not really a polynomial. But sometimes fractions like this pop up in Calculus 1. The question is, how do we try to simplify this? How do we use the same techniques as we used before? Well, one thing that you can do is you can factor. If you try to factor this, there's nothing for you to factor. If you try to factor that one, again, it doesn't seem to be something that we can factor here. In those cases, what you do is you multiply with a conjugate, as it is called. And the conjugate is basically every time you see a minus b, the conjugate of that is a plus b. So every time you have two expressions here subtracted by something, you put plus, or every time you see two things that have a plus between them, you put a minus b. So these two guys are conjugate pairs. All right, so conjugates go always in pairs. So as you can see over there, I have the square root of x minus 4. The conjugate of that is basically the square root of x plus 4. So what I'm going to do is I'm going to multiply both the numerator and the denominator with those conjugates. I'm multiplying both so that I don't mess the fraction. If you multiply both the numerator and the denominator of a fraction with the same quantity, it doesn't change. Now what's happening on the top? Look, you have square root of x minus 4, square root of x plus 4. The process that I need to remind you here, and the reason why we multiply with a conjugate, is this one. If you multiply a minus b with a plus b, what you end up having is a squared minus b squared. This is a very well-known identity, the difference of two squares. So by multiplying with a conjugate, we force this identity to appear. This means that we'll have square root of x, and the whole thing squared, minus 4 squared over, I'll just repeat what's down there. I'm not going to do the multiplication, and you should not do the multiplication either, because something's going to pop up immediately. On the top, what you have square root of x squared. That gives you x, right? If it was the other way around, it would give you absolute value of x. But since it's square root of x squared, you already assume that x is positive so that you can take its square root, okay? So then square root of x squared just gives you x. Minus 4 squared gives you minus 16. Now we put the denominator as it is. Notice the following now. X minus 16 is on the top, x minus 16 is on the bottom, all right, as a factor. So you can cancel these guys out and leave a 1 on the top, since we factored out the x minus 16, and square root of x plus 4 on the bottom, all right? So this fraction can turn into that fraction. Now you might ask, why do I need to do that? Well, first of all, this one is simpler than that one. And second, there is a point that we're trying to find limits where these things appear. You'll see what limits are in a little bit. And then you can figure out the limit this way, but you can figure out the limit that way. All right? Anyway, so this is multiplying with a conjugate, a very cool concept here when we're doing rational expressions.